Continuing our examples of antiderivative processes, there is one that is worth investigating a little more deeply. For example, and that is the function of, together for example, and that's the function 1 over x. So it's a bit of a special case. Let's explore that. Sketch the region implied by the integral -3 to -1 of 1 over x dx. So this is our function. So if we were to sketch that function, it would look something like this. 1 over x, y equals 1 over x, but it also applies over here, has a horizontal and vertical asymptotes like you're familiar with. And if we want to integrate from -1 to -3, that would be the region defined here. It would be a negative quantity. The integral would be negative because the function's below the axis. These values are negative, but otherwise we're good to go. Let's use the fundamental theorem of calculus for evaluating. So the integral of 1 over x dx from -3 to -1, we would find that by starting with our function itself and finding an antiderivative. And we've done that earlier. We said if we differentiate ln of x, then we get 1 over x back. And we might add a plus c. So we're good to go. We're going to evaluate our antiderivative at the upper point, -1, and evaluate it the lower point, -3, and that'll give us the exact area or the exact total integral value represented here. So we'll have ln of -1 plus c minus the ln of -3 plus c. Here's where we hit the snag. The ln of -1 is not actually defined, nor is the ln of -3. But this is a perfectly valid integral that I want to evaluate, so what went wrong? Well, it wasn't so much that things went wrong, it's that things are a little more complicated than we might have anticipated at first. Let's do a quick sketch going back to stuff that we've seen before, material we've seen before. If we graph ln of x, we know it looks like this. And if we graph its derivative, 1 over x, we know it looks like this over here. In other words, if we look at slopes on this graph, and we look for values on this graph, where the slope is 1, the value is 1. When the slope is getting flatter, the values are getting smaller, still positive, and we can also see we get steeper and steeper slopes. Those translate to higher and higher values. So we actually have a nice relationship between the graph of ln of x and its derivative, 1 over x. What we're doing now is we're filling in the other side of this graph, though, for 1 over x. Remember, we're trying to look at antiderivatives going back up from this function to back to ln of x, but we don't have anything sketched out here in our naive approach that we first started with. However, if we look at the values here, a value of -1, well, imagine I want a slope of -1 up here, or values that are small and negative, that would be like small negative slopes. If you start to sketch this mirror image graph and look for the slopes here, the slopes here, the slope at this point here would be the slope of -1. Hey, that perfectly matches the value on this graph. Slopes are getting more and more negative. The values are getting larger and more negative. Hey, this mirror image of the ln of x graph, when I take its derivative, I get the 1 over x graph even for negative x's here. But what is this graph here? Turns out, all we need to do is put absolute value signs around that x. That takes a moment or two to absorb. But what does that mean? It means if I put a negative value in to my function, negative x's, say -2, I want to get exactly the same thing that I got when x was positive. So what does this do? It takes a negative number, makes it positive, and then finds the function value of ln. That results in a mirror image of the branch that we have for positive x values. If you need to, plug in some values to confirm that this is actually what generates this second branch here in the way we're sketching it out. But I can confirm it's true. Ln of the absolute value of x, when you differentiate it, when you get slopes at each point and compute the value of the slopes, will give you exactly the 1 over x graph. And that is going to be our recipe for resolving this issue we had here. We don't take -1 and -3 and let's take the ln of those. We take the ln of the absolute values of those. And that is just ln of 1 minus ln of 3 plus c minus c cancel. And we end up with -1.0986. Now, does that negative pose a problem here as a final answer? Absolutely not. Remember what we're calculating. We're calculating the integral under the graph of 1 over x from -3 to -1. This is all below the axis, so we expect it to be negative as a final answer. That makes total sense. What we had as a problem was ln of negative numbers along the way, and we've resolved that now by recognizing that the antiderivative of 1 over x is ln not just of x, but ln of the absolute value of x. So it is worth making the adaptation to our earlier antiderivative table. In that table, please do correct your ln of x, 1 over x. In that table, please do include this new ln of the absolute value of x as an antiderivative for 1 over x.